Creating functions. In this nugget, we're going to look at another programmable database object known as the function, or when we create them, user-defined functions. We'll define what a function is. We'll compare them to stored procedures, because one of the biggest questions that'll pop into your mind is, what's the difference between a stored procedure and a function? They both seem to serve the same purpose, but there is indeed quite a few differences between them. So we'll look at those differences, and then we'll also talk about the different kinds of functions that we can create. From there, we'll jump into the Virtual Nugget Lab. We'll show you how to work with the built-in functions and even create all the different types of user-defined functions. Let's get started. So a function in SQL is very much like a function in your typical programming language. It's a named block of code. We call it by the name. We can pass parameters to it. It's going to perform an action and return a result. We can use functions from pretty much everywhere in SQL. We can use them in queries, whether it's in the select statement, or in the from clause, or in the where clause. We can call them from stored procedures. We can call them from views and triggers. We can even use them in constraints within our table for default values and check constraints. They give us a lot of the same benefits that stored procedures give us. And the real big one here is that they allow for modular programming. So we can create that function once and then use it from many locations, right? And now if we didn't have a function, say we had a block of code that we're constantly writing, and we put that block of code in all of these spots, what happens when we need to change that code? Yeah, we need to go touch everything that utilizes that code. So by putting in a function, we have one single location. If we need to make a change, we make the change in the function, and everything that utilizes that function automatically gets that change. So the biggest question that's going to come to mind, and by far the most popular question when it comes to programmable SQL database objects, is what should I use, a function or a stored procedure? They both seem to do the same thing, right? They can both accept parameters, they're both going to run a block of SQL, and they're both going to return a result. And while they look very similar on the surface, they're actually very different beasts under the hood. And a lot of the times that question is going to be answered for you depending on what you're trying to do, because they both have their own set of restrictions. Here are the biggest differences between stored procedures and functions. Functions can only read data. They can't do any sort of data manipulation, so you can only run select statements inside of them. Stored procedures, you can run anything across DML and DDL. Functions have input parameters only. That's all they accept. No output parameters and only a return value. Stored procedures can accept input and output parameters. Functions cannot call stored procedures, but stored procedures can call functions. Functions can be called from the select statement. Stored procedures can only be executed. Functions cannot contain any transactions. And again, that goes along with data manipulation, because generally when you're manipulating multiple tables simultaneously, you're going to wrap it in a transaction so they're all treated as a single atomic unit. And that's what stored procedures are good for. Functions must return a value. They're not just going to do some sort of processing. They need to return a value. And stored procedures may or may not return a value. Functions are really good for a couple of things. Number one, utility type stuff. Maybe I'm constantly formatting phone numbers. Rather than have that huge block of code in all of my queries, I could turn it into a function and call it from anywhere where I need to format a phone number. Or maybe I'm storing the length of a file in bytes, and sometimes I need to convert it to kilobytes or megabytes or gigabytes. I could create a function to do that for me, and then again, call it from anywhere that needs to convert that to a specific size. They're also good for aggregating or summarizing data, or even just doing simple lookups. Stored procedures, on the other hand, are great for that heavy data processing or data manipulation, or again, as an interface for applications into the database. Now, the different kinds of functions we're going to be working with. We can create our own functions, and those are called user-defined functions. We can also reference built-in functions, which we've been doing quite a bit throughout the course. We've got functions across all the categories you can think of. We have string functions, date functions, math functions, system functions, security functions, and I'll show you where you can find those functions and get help on them, and we'll also take a look at how to use some of the more popular ones out there. We also have scalar functions. These are functions that perform an action and return a single value as the result. We also have table-valued functions. So scalar functions you're generally going to use in your select or your where clauses. Table-valued functions you're going to use in your from clauses, because we can actually select from a function or join to a function, because these return a table. And there's actually two kinds of TVFs, as we call these. One of them is inline, and this is a function with no body. It's just a return with a query. These are really good for creating what are known as parameterized views. We can make our views a little more dynamic. And then the other one we have is a multi-statement table-valued function. And a multi-statement table-valued function is one that can have multiple statements inside of the body. So we'll generally here define the structure of our table, do some work, fill that table up, and then return that table as the result. All right, let's jump into the Virtual Nugget Lab. I'll show you how to work with the built-in functions, And then we'll create our own user-defined functions. I'll show you how to create a couple of scalar functions and one of each type of table-valued function. All right, here we are on our database server here in the Virtual Nugget Lab. Let's bring up SQL Server Management Studio. We're going to be working with our project here called Creating Functions. First thing we should do, if you want to follow along in the demo, is run setup.sql. That will get our music database into the state that it needs to be to run all of our demonstrations, so we're all working on the same page here. And then let's open up built-in functions. Let's start by just taking a look at some of the more popular built-in functions across many of these categories. Now, before we dig into the code here, let me show you something extremely useful. If you want to get a list of all the built-in or system functions here in SQL Server, just expand any database, expand programmability, expand functions, and head down here to system functions. All the functions are broken out by category. So here's all the aggregate functions. We've looked at many of these: average, count, min, max, sum. And if you hold your mouse over any of these, you'll get a brief description of what they do. If you expand them, you can see their input parameters and their data types, as well as their potential return types. Pretty cool, right? And you can do this for all these categories. So date and time, a lot of useful ones inside of here. And we've worked with many of these as well. Date diff, date part, date add. And you'll be working with these a lot when you're writing queries, because date manipulation is a very, very common thing to do, especially when you're writing queries that are going to back reports. Let's see another one. Oh yeah, get date, we know that one. Is date, that's extremely useful. You can pass in an expression, whatever it evaluates to. Is date will return true if it's date, false if it isn't. String functions, lots of string functions. Again, these you will be getting very familiar with, especially things like len for counting the length, left, trimming white space off of them, replace is very popular, substring, stuff, all kinds of stuff inside of here. Some of them fun, some of them useful. So that's where you can find all the system functions. And also, again, if you want to get help with any function here in SQL Server, all you need to do is give it a highlight, double click on it, shift on the keyboard, F1, that'll pop it right open, give you the syntax, give you an idea of what all the parameters do, and even give you some examples. So here's the date part function, for instance. We pass in the date part and we pass in a date. Our date part can be any of these: quarter, month, day of year, day, week, weekday, hour, minute, second, milliseconds, all the way down to nanosecond. Crazy, right? So you pass in your date part, you pass in your date, and it'll return that part of the date. Extremely useful. And of course, we've got some examples down here as well. All right, let's look at a couple of examples here. So here's a bunch of string examples. Here's a very simple one: upper and lower. So we'll grab the name, we'll upper the name, and then we'll lower the name from our certification table in TestDB. And look at that. There's the standard version, how it already is in the database. There it is upper, there it is lower. Pretty basic there. Also, len is going to be very popular, especially when combined with other functions like substring, because that's going to give us a count of the total length of the string. And usually you'll be using that for figuring out, when you're using substring, what your positioning should be. Let's see, we also have replace. Oh, this one's extremely useful. So this is going to grab the name, and it's going to replace the name column wherever it says MCSA to completely spell it out. And we'll call that column new name. Check it out right here. So it's going to say MCSA, Microsoft Certified Solution Associate. That is also an extremely useful one. And then we also have substring. Again, this is what allows us to extract specific parts of a string out. And how it works, and you can hold your mouse over it to actually see the parameters here. There it is. We have our expression, which is usually going to be your column, and then your starting point and how long you're going to count from that starting point. So if we highlight this here, we're just grabbing the starting at position 1 and counting over 2. 1, 2. So it's grabbing the first 2 characters here from the name of our learner. Date and time functions, all very useful. Get date will give us the current date and time. Date part, useful for extracting specific parts of the date. So in this one, it's going to take this date acquired and pull out the year as a column, the month as a column, and the day as a column. And then date diff, also extremely useful. Here we pass in our interval, right? It's going to be all the same intervals we looked at when we were looking at date, month, or in help. Year, month, day, all the way down to nanosecond. And then we pass in our begin date and our end date. And it'll give us the difference between those based on our interval. So here we're doing the same thing as we did above. Give us the difference between all of those. So here's the date. Here's the years from now since that date, the months since that date, and the days since that date. All of those really useful. We've got security functions like suser and sname. Useful, especially when we're creating auditing tables. We want to figure out who's doing all these DML operations. We can track exactly who did it with that function. And then we've got system functions. We can figure out what computer this query was ran against, what machine, that's host name. IsNumeric is another one, very much like isDate, that will let us know when we pass in an expression if it is indeed an actual numerical value or if it's not. And then new ID, a useful system function for generating GUIDs or GUIDs, globally unique identifiers. I'm just keep hitting F5 here and getting a new value every time. One of my favorite things to do is to learn new functions. And I always tell people that are learning SQL and people even that are experts is, hey, you should learn a function a week until you know them all. Because the more functions you know, the more tools you have at your disposal, the more problems you'll be able to solve when they come your way. And I would start with the string and the date time categories. Those contain functions that you'll see most often in SQL and you'll be using most often when writing SQL. All right, let's bring back Solution Explorer over here and let's create some user-defined functions. And we're going to start here with scalar, just a basic scalar user-defined function. So our first example here is creating a scalar user-defined function. It's scalar because it's going to return a single value. And this is actually the perfect example of a utility UDF. Because if we look in MusicDB, we expand tables, we expand track, expand columns. We have a column in here called milliseconds. And that's not very human readable, right? Generally, when people are looking at tracks and albums, they want to see the length of each track and the total length of the album in a human readable form like hours, minutes, seconds. And that's exactly what we're going to do with this scalar UDF. So here's how we create it. We call it create function, define the name, that's our named, that's how we're going to reference it and call it. Define our input parameters. Here we just have one called milliseconds. That's of integer data type. That mirrors the data type of our milliseconds column here. It's going to return the data type varchar12, just a character column that we're going to return that's 12 characters in length, or I should say data type, not column. Then we say as, and then we define our code block here inside of a begin and end. And how this works is we're going to call date add, and we're going to have our date part be milliseconds. And I use shorthand notation there, but we could easily do this. There we go. That makes it a little more readable. So millisecond is our date part. We're going to pass in our variable here, our input parameter, and that's going to return the date type, data type. And that's why we're using the convert function to convert this to a character using the format code 114, which is going to give us the format that we need, which is going to look like hours, minutes, seconds, dot, remaining milliseconds. So let's go ahead and create this. And you know what? We're going to need to create this inside of our MusicDB. There we go. And now we can call it from anywhere. And here's a good example. Here's a very basic query. It's going to pull back the name of the track, the milliseconds in actual milliseconds, and then we're going to call our function passing in that milliseconds column as the input parameter, and this is going to alias as length from our track table. And there's the results. Check that out. Name, milliseconds, and length. Let's look at another one that works with data. So this is going to do a lookup here. Here's another scalar UDF. This accepts three parameters, the album, a begin date, and end date. And what it's going to do, it's going to go and calculate the sales for that album between those dates. Another pretty useful function here. It's going to return an integer data type, and inside of the body here, we're doing things that are a little more complex, right? We're defining a local variable, and then we're setting that equal to the sum of all of this query, and we're using those parameters inside of the query here. And it's still going to return a single value, though, which is going to be total sales, which is why it's still a scalar UDF. So let's go ahead and create this function, and now we could call it multiple times. And here we'll just write a simple query that's going to return the title and then call our UDF, passing in the album ID from this query, and then the date range 1/1/2009 to the end of 2009. So this will do this for every single album here inside of that table. And there it is. There's the total sales for all of the albums within. Cool. So that's a good example of using a scalar UDF to go out and do a lookup. Let's move on to table valued functions. And we'll start with an inline table valued function. And remember, an inline TVF is one that is just simply going to return the results of a query. And these are best used to parameterize views. So generally you're going to reference views inside of here and put parameters on top of them to make them more flexible and dynamic. But here we just have a simple example that's going to return albums with tracks. And we're going to pass in the number of tracks. And that's going to give us the albums with at least that many tracks with them. So here we're creating a function. We're passing in a name, defining our input parameter, and here we're saying returns table. Now we're not defining the structure of a table. It's automatically going to infer the structure from the results of the query. So whatever data types the columns return and their names is what is going to make up that table. Then we do an as, and then we do a return and follow that up with our query. So here's our query utilizing our input parameter, and that's all there is to it. Once we create this function, now we can utilize this function like it was a table. So here we're going to do a select star from the function, pass in 10 as our parameter here, and this is going to give us all albums that have 10 or more tracks with it. And we can also join then to this. So check this out. We are going to join to this. Now watch this. Look at that. We just joined right to that. So we join to that because it has an album ID inside of it, so that's what we joined on, and that will then give us access to all the other columns from the album table that we joined it to here, our base album table. So yeah, you can create TVFs that return tables and then join to them. Lastly, let's take a look at a multi-statement table valued function. Again, this is a function that allows us to do more inside of the body. In other words, we can do conditional logic, run if then else statements, we can do loops, and we can make decisions inside of the body before filling up our table of data and returning it back to the caller. So here we're going to do, again, create function, give it a name. You can have input parameters. I'll actually show you how to alter this to add one here shortly. And then we're going to return a table data type. But notice here that we're defining a table variable. We're also defining the structure of the table. And the reason we're doing this is so we can reference it inside of the body. We're going to need to fill this data up, or this table up with data before we pass it back to the caller. So we define our table structure, we do a begin and an end, and inside of here is where we can run anything we need to. You know, we can do all kinds of things to shape our data. We can get data from multiple sources, then throw it inside of this table variable, do whatever. Now we just have a very simple one where we're going to insert into our customer order table variable the result of this query right here, which, by the way, is going to get the most recent customer order. So let's go ahead and create this function. All right, and now again we can treat it just like a table. So just running this function will get us the most recent order in the system. Again, we can also join to it. So we can join to our customer table if we want to get more information about the customer that made the order. And there it is. Now let's turn this up just a notch here by adding a parameter here. Let's say that we want this to act a couple of ways. Number one, we still want to get the most recent overall customer order. But let's say we also want this function to have the ability to get us the most recent order for a specific customer. Right, so let's alter this function here. Let's run an alter, and let's create a customer ID parameter. It's going to be an integer data type, and we need to make it nullable just in case we want to use it like we were using it before. Now we just need to modify this little bit of code down here. I'm going to say is null, and you're going to see this quite a bit. And once you learn this technique, you'll be using it quite a bit as well. But essentially what we're doing here is we're saying if this customer ID is null, then just use what we previously had, the invoice.customer ID of our query, which will pull back all the customers. So if it's not null, though, it's just going to use the value, and this will only contain the results for a specific customer. All right, let's highlight all this, hit execute, good to go. And now let's see if it still works like it did before. Oh, it doesn't. Oh, you know why? Because we still need to, they don't support optional parameters, so we're going to need to pass in an actual null value. There we go. Now watch. Boom. There, just like before there. But let's say that we wanted to pass in a specific customer. Let's see what customer number 2 has. Look at, there it is. There's just customer 2's previous order. Now you can find your own UDFs underneath programmability in the database, expand functions. Here's our table valued functions. There's both of them that we created here. And here's both of our scalar valued functions. In this DBT Nugget, we learned what functions are all about. We took a look at built-in functions, user-defined functions, compared them to stored procedures, and saw how to create and work with them. I hope this has been informative for you, and I'd like to thank you for viewing.